We're going to find a common base for both sides of the equal sign, and then we're going to set the exponents equal to each other. The idea being, if we have 5 to the x equals 5 to the y, right? Then what that necessarily means, if we have the same base, that must mean that x is equal to y. They have to be equal to each other, right? If I had like 5 squared equals 5 to the power of x, then x must be equal to 2, right? The only thing I could put there in order to make them equal is a 2, right? So x and y in this instance here must be equal to each other. 2 and x must be equal to each other. If I added a plus x here and a plus 10x there, right, then 2 plus x would have to be equal to x plus 10x, right? So this has to be our option. We don't have another option. So using that idea, we are going to change the bases into something that they have in common. What I mean by that is, like, I need a base that can be the same for both of these numbers. What is in common between 27 and 9? Yes, I've got some 3s in the chat for sure. I've got 3. 27 is 3 to the what power? 3, yes. And 9 is 3 to the squared, yes. Thank you. So I turned 27 into 3 to the third, and I turned 9 into 3 squared. And then I still have these same exponents on here. Right, this exponent is still here. This exponent is still here. Using my power of a power from last week, when I have an exponent and then another exponent outside of the parentheses, what do I do to make this one like exponent set?
You multiply the exponents?
Yes, for sure. You multiply the exponents. So I'm going to go ahead and multiply 3 times x, 3 times -2. So I have 3 to the 3x minus 6 is equal to 2 times 2x, 2 times 5. So 3 to the 4x plus 10. Do we have the same base? Do we have the same base? Yeah, we do. What does that mean about the exponents? If we have the same base, they are equal. The exponents would be equal to each other. So basically, I can make a more simple equation. 3x minus 6 must be equal to 4x plus 10. I'm basically saying the 3's, adios amigos, and then we are going to solve the exponent equals the exponent. This is very quick. Go ahead and solve that. Try to get an answer. What does x equal? I've got 1 vote for -16. Another vote for -16. We're going to get the -16. Subtract that 3x, subtract the 10. You should get -16 equals x. That is indeed my answer. You can check it. What you would do to check is take the -16 and plug it back in here. So 27 -16 minus 2 should be equal to 9. 2 times -16 plus 5. So that means 27 to the -18 needs to be equal to 9. This is -32 plus 5, -27. So 27 to the -18 needs to be equal to 9 to the -27. I can go ahead and do that on my calculator, although those are going to be wicked small numbers. I think I already did it. Yes, I did. See how here you have like both of these numbers are equal to each other, right? That means that this is a correct answer, right? We have each of these are equal to each other. Therefore, we know our -16 is correct. Have we seen this before? Let me poll you. I have a new poll. Have we seen this before? Yes, no, maybe so. Okay. That's good information for me. It looks like we're pretty split in terms of yes and no. I'll show you. It looks like like 10 of us have seen it, 6 of us have said no, and then 6 of us were like, I don't know if I've seen this before, maybe, but I don't really remember. So that's good. That's good information for me. Thank you. Okay, so the crux of the situation is we have to find a common base, and then we need to set the exponents equal to each other. So if I'm looking at this problem here, I'm looking particularly at the 4 and at the 8, right? What base number could I have between 4 and 8? Can I use the number 4? Could I use 4 as my base? Yeah, no, you can't. You're totally right, Devin. No, I can't, because this is 4, like this, you could have like 4 to the 1, but then how would you make 8? It's not 4 squared, right? It's like 8 is not 4 squared. 8 is 4 to the power of 1.5. But we don't necessarily know that. Wow, my lag is out of control. Well, let me see. Okay, we're gonna roll with it, but we'll see. Okay, so I can use 3/2. That's complicated. I'm gonna go ahead and use the number 2, right? So 4 is 2 squared. How do I designate that it's on the bottom of the fraction? Right, so this is 1 over 2 squared. Yeah, Walter, I'm going to use -2 for sure. So 1/4 is 2 to the power of -2. Still have x plus 2. What am I going to turn 8 into? Two to the power of 3. Yes. 2 to the power of 3. Yes, Carly. Thanks, Devin. So we have x minus 4 here. Go ahead and finish working through this problem. Try to figure out what x equals using the same steps. Now that they have common bases, use the same steps as the last problem. Let me know when you get an answer. It is okay to get a fraction. And leave it in fraction form if you get a fraction. I'm leaving you a clue. I've got a couple different answers. They both are fractions so far. I've got -2x minus 4, 3x minus 12. If those are equal, therefore their exponents are equal. -2x minus 4 equals 3x minus 12. I'm going to go ahead and add the 2x over here. Add the 12 over there. I get 5x equals 8. Divide by 5, divide by 5. X equals 8/5. Do not forget to distribute, right? Make sure you are distributing here. And then make sure you're calculating correctly. Give me a quick 5 to 5 here. How are we feeling about the last 2 problems? Zoom out so you can see. How are we feeling about the last 2? All right. Cool. This is where we're sitting, mostly 4s, some 3s, some 5s. I like it. All right, let's try another one. Okay, so those are like that level. And then we do have this situation. So we have e to the x equals e to the x squared times e to the negative 2. What is different about this problem than the problem that we saw? I'd say there are 2 major differences. What are the differences? So they have the same base, which is true. That's awesome. So they're not different bases. They are already the same. There's no number basis. Yeah, so we have E, and E. There are 3 of them. There's E, and E rather than just 2 of them. And the exponent has an exponent. We have the E and the E. The x is squared. Wow, you guys found way more differences. I said there was 2. There's like 5 or 10. Wow, y'all are great. There are 2 unknowns. Yeah, we have x and we have x squared. So technically there's only 1 unknown, but we do have that x squared there. Two places where x is. Okay, cool. So Diana actually gave me a clue in the chat, which is that she wants us to multiply. And we are going to combine these 2 together because in our like original idea of this, we need to just have 1 base on one side and 1 base on the other. So we need to combine these together in order to be able to continue this problem. Using our exponent rules, when I have the same base being multiplied, what do I do with the exponent? I add them. Yeah, I'm going to add this exponent with that exponent. So same base, e, but I'm going to have x squared plus a negative 2. So I'm just going to write minus 2 like that. And this is equal to e to the x. Does anyone know what e is? Anyone know? It's actually a number. I would say the number e. Does anyone know the number e? Kids to teach something new. Oh, no. Galilee knows it's 2.7. It is not 2.7. Yes, Ali, it is our base. E is just a number. It is approximately 2.7, like more numbers after that. It's like pi, right? It's like pi. Pi is like 3.14159, like goes on forever and ever. It's an irrational number. E is another one of those irrational numbers. It stands for roughly 2.72, I think, 2.71, 19 or something, roughly 2.7. It doesn't really matter, right? Because if this was a 3, we're just going to cancel them. If it was a 13, we're just going to cancel them. If it was like a 213, we're just going to cancel them. It doesn't really matter what our base is, because as long as they're the same on both sides, then we're going to like, basically we're going to say like, it doesn't matter what our base is, we only care about our exponent because that's where our variable is. So we'll take all of this back. So since our bases are the same, what does that mean about our exponents? It means that our exponents must also be the same. So our exponent is going to drop out here. X is equal to x squared minus 2. All right. I have x squared and x. Can I just like take the square? Whoa. Can I just take the square root? Can I do this? Is this allowed? No. Yeah, Brandon. Good mathematical instincts. No, you can't do that because we have the subtraction sign there. We can't just take the square root. We could, I guess, take this and like that, but then I don't know where we're gonna go from there. So I don't want to do that. How do I do this? Fatima is already ahead of me. I could move the 2, but really I want to move the x over here. Here's my reasoning why. Yeah, let's move the x because I want to keep x squared positive. If I move the 2, then I also have to move the x squared, right? So let's move the x over. So I've got 0 equals x squared minus x minus 2, like that. So yes, Axel, and yes, Fatima from way earlier. I'm gonna factor this, right? I wanna set it equal to 0. Now I'm gonna factor what multiplies to get -2 and adds to get -1. I've got -2 and +1. Do we agree or disagree? Looks like Fatima agrees. David agrees. Cool. All right, 3 agreeing, so I'm going to move forward. What is the x value coming out of each of these? X equals 2 and x equals -1. Absolutely. These are my 2 solutions to this problem. It has 2 solutions because if we have x squared, we got to have 2 solutions. All right. Let me see. How are we feeling? That one was slightly more complicated. How are we feeling about this? Cool. All right. We'll share here. You've got mostly 4s, 3s, and 5s. All right, let's do the last one. All right, are you ready for an epic problem? I'm so excited. This is our epic problem. Epic, epic. I'll give you a moment to write it down. Give you a moment to write it down there. All right, getting ready. All right, how many bases are currently in this problem? How many different bases are currently in this problem? 3, yes, we have 16, 8, and 4. We have to make those all the same. With 16, 8, and 4, what could we use as our common base? Yes, for sure, we can use the number 2. It might be tempting to use 4 because our brains are thinking, oh, those are divisible by 4. Yes, however, remember 8, right? We're not gonna be able to say, like 4 to the power of a whole number. Again, we could use a fraction, but that seems more challenging than necessary. So I'm seeing lots of 2s. I'm going to turn all of these things into 2. So I'm going to turn 16 into 2. I'm going to turn 8 into 2. And I'm going to turn 4 into 2. Right? So we have, I'll just go ahead and write my exponents here, the ones that are already there. So 16 is 2 to what? 16 is 2 to 4. Yes, Diana, thank you for writing all that out. 8 is 2 to what? 3, yes. 2 to 3. 4 is 2 to what? 2. Yes, like so. Okay, someone give me a strategy. Give me a strategy. How can I move forward from here? What should I do? Any ideas? Oh, cross the 2s. Interesting. We could technically, don't do this on your paper. We could technically do 2 to the power of 3x minus 3, like cancel this and cancel that and put it over here, 2 to the power of 3x minus 3. You could actually do that, right? That's not that complicated. However, I think it will be more simple to do a different one, a different method, which is to simplify the fraction, right? We cannot cancel these like that. That is not allowed because we have not yet talked about these exponents here, right? So we need all of the exponents to be simplified before we do that. So let's go ahead and simplify the fraction. Thank you, Araceli, for that suggestion. So I'm going to have 4x, 4 times 2. So I'd have 2 to the 4x plus 8 over 2 to the 3x minus 3 equals 2 to the 6x plus 2. All right. Now that I have my fraction here, right, I'm going to use the quotient rule. What should I do with my exponents in order to simplify this fraction? Oh, I see Yali has it in the chat. We're subtracting because of the division. Yeah, we're going to subtract this exponent, right? We're going to take this and subtract 3x minus 3. So I have 2, let's see, 4x minus 3x would be just x. And I have 8 minus negative 3. So 8 plus 3 would be 11. Is equal to 6x plus 2. Okay, it's looking more simple. What can I do now? Yes, set the exponents equal. I've got x plus 11 equals 6x plus 2. I set the exponents equal. I can combine like terms, but really I'm like moving them across. So I'm subtracting. I'm getting the like terms together. I am subtracting 2. So I have 5x equals 9. Divided by 5, x equals 9/5. 9/5. Whew. Okay, our epic problem, we did it. Epic. I love it. All right, y'all, and we finished with like a lot of time to spare. I'm so proud of us, even after talking about plants for like a good 10 minutes earlier. Okay, so we have, actually, before I move on, are there any questions? And tell me, how are you feeling? How are you feeling? We've seen now 4 examples of this type of problem. How are you feeling? Are you ready to practice? All right. Ooh, we're looking more confident. I appreciate that. All right, here's where we're at. Like just one more 4 than 5, but also a lot of 5s. We've got a couple 2s and 3s, no problem. That's why we have all stars. All right. Okay, let me show you what your homework is gonna look like. So you have your notes here. You're gonna pop in a picture of your notes. There are 2 parts on this one. The first one, everyone is going to do all 6 problems here, so 1 through 6. You have 8 available answers, so make sure you figure out which of them you're going to use. If you need help, there are videos. I know this is fancy. There are videos for every single problem. So if you want to watch all the videos for every single problem, you can. I would not recommend that. I would just recommend watching the videos if you get stuck. But you are welcome to watch all the videos if you wish. That is for part 1. Everybody is doing 1 through 6. That is your like beginner, like the beginning of your homework. Then I want you to gauge for yourself. If you would, there are 2 options for part 2. You're going to choose which one is best for you. Both options are going to earn the same number of points. So it's not like option 1 is less and option 2 is better. That's not a thing. But option 1 is going to be our focus in section. If part 1 felt hard, or if you want to stick to the basics, or if you like IXL, there is an IXL option for option 1. If you want to like go to the next level and take like an additional challenge for yourself, you can try option 2, which is 8 additional problems on paper. They're a little more challenging, although not extremely challenging. So option 2 is on paper. So you can decide which one works best for your brain. Do you like the way that IXL challenges you, or do you want to continue working on paper? You have answers there. That is the end. It is all on one page. Check that out. It's all on one page. I'm real pumped. Tell me right now what you're, well, you can make this decision for yourself later, but tell me if you're thinking about option 1 right now, that would be option A, or option 2 right now. Like if you had to make a decision before doing part 1, which would you think? Thanks, Kayla. You should see a poll in front of you. Marley, yes, I will give you extra credit if you do both. So if you want to do both, you're welcome to do both. If you miss IXL, today's your day. Today's your day. You can make it happen. All right. Miss, oh no. Trauma. Some people love IXL, some people are not about it. Angel Perez, that's weird. Depends on your mood. Christine hates it. Some people love it. Some people have trauma from it. I hear you. All those things are valid. Okay, check this out, y'all. This is why I gave 2 options. We're like half and half split on which option people would choose. So I'm glad that everyone's gonna get to do what they want. So for the rest of our time, you still have your breakout rooms open. If you want to work together in your breakout rooms that you chose, you can jump into your breakout rooms now. I'll pull this back. Well, you can jump off whenever you're ready. I know it's 10:27, so if you're ready to jump off now, you can do that. If you want to jump into your breakout rooms, we're going to hang out for a little bit. So if you don't have to go to Spanish, you can do that. Otherwise, have a great weekend. If you want to do 1 or 2 problems before you leave, just chat me which problem you want to do, and we can make that happen. Otherwise, happy weekend, my friends, and I will see you soon. Bye, Gally. Gotta E, totally.
Bye, Miss.
Bye. Bye, Mia.
Sorry, my brother's here in my room.
Oh, hi, brother.
Yeah. She said hi. He said hi back.
Oh, hi.
He's a freshman, so he goes to our school right now.
Nice.
His advisor is Mr. Lopez.
Oh, Lopez.
Yeah.
Cool.
Yeah. All right. Bye, Miss.
Okay. Bye. Okay, Sara E. What did you make your common base?
I meant like number 6 in the bottom.
Oh, my bad. Number 6, this one here.
Yeah.
Oh yeah, complicated. Sara E, have you been working on this like the whole time we've been talking?
I worked on it yesterday and I just got stuck on number 6.
Got it. Wow, you are super on top of it. Okay. So for number 6, what have you done so far? Have you done anything so far?
I tried it, but I got the answer so wrong, so I gave up.
Okay. So what did you think you could use for your common base with 8 and 2 and 32?
2.
2 for sure. So you have 2 to the 3rd, and then x minus 1, and you have 2 to the x, right? Already there. And then 2 to the 5th, and you have x plus 3. Does this seem right so far?
Yes, I did that.
Okay, cool. And then did you distribute the exponents?
Yep.
So you have 2 to the 3x minus 3 over 2 to the x, like that?
Yes.
And 2 to the 5x plus 15?
Yes.
Cool. And then did you subtract the x because of the division?
I did not do that part.
Yeah, so that's what I would do next is
Okay.
I'm going to combine the fraction I'm gonna do 2 to the, remember like when it's division, you're subtracting
2 to
that
the
exponent.
x
2 to the 2x minus 3.
minus 3.
And then we have 2 5x plus 15. So there you have a couple options now, Sarai.
Okay.
One is you could say like, okay, this square root sign is like a 1/2 power. So you could make it like 1/2. And then you could take the 1/2 and distribute it in here. Since we're working with equations, I actually think it would be easier to just say, okay, what's the opposite of a square root? It's a square, right?
Yes.
So then if I square that side, I also need to square this side. So square root and square are going to cancel and leave me with 2 to the 2x minus 3 equals, and then the 2 goes on the 5x and the 2 goes on the 15. So 2 to the 10x plus 30, like that.
Okay, thank you, Miss. See, that's the
You're
part
welcome.
I did the square root
Uh-huh.
and the square in the beginning.
Ooh, that probably could have been okay. Like up here, you did square root like this and square
Yeah.
like that.
Yes.
Let's see. So square root and square, and then this would go on here. So you'd have 8 to the x minus 1 over 2 to the x equals 32 to the 2x plus 6. You started like that.
Mm-hmm.
And then we still would have had 2 to the 3rd to the x minus 1 over 2x, 2 to the 5th now with 2x plus 6, 2 to the 10x plus 30. Well, that's good. I'm still like recognizing that, right?
Yeah.
And then this one would have been 3x minus 3 over 2x. And then you're going to subtract the x. So then you'd have 2 to the 2x minus 3. Same.
What is it? Okay, Miss, I don't know why you did yesterday. I don't
That's
know why
okay.
I did.
Yeah, but good news is that like the way that you were thinking to get rid of that square root and to use the square, like it totally works. You probably just like forgot to distribute or something.
Yeah, I don't know why I did, but
Yeah.
it was wrong.
But
Okay, thank you, Miss.
yeah, you're welcome. No problem. We'll see you
Bye.
later. Bye.